secants and tangents. So let's first of all, I guess, go back and remember what each of those are. We have been working with tangents. What's a tangent?
A line that barely touches a circle in one spot.
So when you say barely touching, you mean a line that intersects a circle in one spot, right? This guy would be tangent. And right here is our definition of secant, a line that intersects the circle in 2 points, right? It passes through. If it didn't pass through, the arrows weren't there and it stopped, what is that? Chord. Okay, you guys are getting great at this. This is one of those places that I kind of like to color code what's going on. Let me grab my highlighters here. There they are. So pretty much we've got 3 theorems here on this page, and then we'll have a problem that highlights each one of those theorems. I think sometimes half the battle is understanding what on earth it's really saying. It's kind of a whole bunch of jarble. I think that's why you guys got confused yesterday when I left it for you to do on your own a little bit. All right, so when 2 secants, we've got 2 lines that pass through our circle, intersect inside of a circle, there's that point of intersection, then the measure of the angle formed is half the sum of the measure of the arcs intercepted. That's a whole lot going on. So I want to show you visually what's happening. If I'm talking about angle 1 right here, angle 1 goes with this arc and this arc. And what it's saying, I can know the measure of that angle if I add these 2 arcs together and split them in half. Okay. Also, then, angle 2.
You just use 1.
Sorry?
You added them together and split them in half.
They're not the same measure.
Oh.
So that's a good question. That's a fair question, but they are not necessarily the same measure. So angle 2 right here, what does it go with? Yeah, those 2, right? All right.
So angle 1 was 56, and AB, wouldn't that mean AB was 56?
So go ahead and explain. What are you saying?
So angle 1 is 56.
Okay.
Doesn't that mean AB?
It means that 56 is half of whatever AB plus DC are, and we don't know that. So we've still got 2 unknowns, right? So if I told you that this arc was, say, 30, could I solve for the missing arc? I could, right? I could say 56 is half of 30 plus, we didn't have AB, right? They didn't leave a whole lot of room for us to write that in there, but this is a good question to pursue, so we'll follow it through. How do I solve this? What do I do? What am I going to get rid of first? Yeah, can I get rid of the half? Times both sides by 2. I'll bring it down here. So that means we would have 108 equals 30 plus AB. So now I know the measure of arc AB. 108 minus 30 is 178. That's what you meant. Okay. All right, this will feel a little bit similar, this second one. Let's see. When we have a secant and a tangent, so we're combining the 2 things we've been talking about, and they intersect at the point of tangency, so right there. The measure of the angles formed is half the measure of the intercepted arc. So here is angle 1. Guess what it is half of? AB. Yeah, AB. Here is angle 2. Guess what it is half of? And that should feel like our theorems when we were working with tangent lines only. Okay. In this case, we've just added a secant and talking about it a little bit differently. Let you catch up on your notes before we go to the next one. Okay, our last theorem for the day. When two lines, chords, tangents, or secants intersect outside. So whatever is going on, they intersect outside. There's that point of intersection. The measure of the angle formed. So what angle is formed? Is angle A the same as that angle? They're vertical angles, right? They're vertical angles. So the measure of that angle, what does it say? Is half the difference of the measures of the intercepted arcs. So now this is funny. Hard for me to understand a little bit, but don't I have the big arc right there? And I also have the little arc, don't I? So it is this one minus that one. So subtract the one above. Let's see if that makes sense. The measure of my angle is half, big one minus the little one. If I went the reverse, what kind of angle would I have if I did little minus big? It'd be negative. We don't have negative measures, right? So that's why you need to make sure that you do the big arc minus the smaller arc. Top two are add. The bottom one is subtract. Okay, let's apply it to these problems right here. What am I looking for? X. How am I going to solve this? Here's the angle, so I'm going to look at its arcs. This one and this one. How did it tell me we were related? All right, we're going to add them. I love it. So the measure of angle X is half 110 plus 138. I heard a calculator pull out, so will you tell me what that is? 124? X is 124 degrees. All right, next one. I've got the arc. I want to know X here. What's my relationship? It's just half, right? So X is half of 150, which is 75 degrees. Now this last one has a little bit of a trick. I've got the measure of my angle here. And what this is showing me is it wants to know the measure of the arc. So we've got this one here, right? So we've got that intersection on the outside. So let's just set it up exactly like we see that formula. It says the measure of the angle. Do I know the measure of the angle? 57 is half of, and I might add to this, big minus little. That just helps me. Big minus little. So half of, which one's the big? 146 minus what? X. Yeah, that's what we're looking for, X.
Would you spell that?
I would be happy to.
Nope.
So when we were solving a second ago, we chose to get rid of that half first, yes? So times both sides by 2, we would have 114 equals 146 minus X. What's 114 minus 146? Negative 32 equals negative X, but you already put the sign in your head, right? So the measure of that arc is 32 degrees. Understanding how those theorems work is for sure half of the battle.